Hi guys! So we are back for another day and we are going to continue our work with functions. And today we're going to be talking about initial value, which is, you guys are going to come to find, is another word for starting point, or in what we like to know it as, y-intercept. So yesterday we talked about slope and today we're going to talk about y-intercepts. All right, let's go. So I want you guys to think about this here. At a school fair, you sell t-shirts for $6 each. You bring some money with you to make change. After selling 5 t-shirts, you have $44. How much money did you bring to make change? So I want you guys to think about that and type out your reason in the question, and then we'll talk about it after. All right, starting right now. All right, now that you've answered it, let's talk about it. So if I sold 5 t-shirts for $6 each, so $5, $6 times 5 t-shirts. So that means that I made $30. And if I have $44, $30 of it was the money that I was given for the t-shirts, which means that $14 was used for change, was brought. So I brought in $30 once I got there, meaning I had $14 to start because the $30 plus the 14 makes the $44 that I had. So just kind of think about that. Again, that $14 was our starting point. Okay, so in a linear function, and we've already talked about this before, there are two different things we need to look at. They're always written in y equals mx plus b, where our coefficient of x is our rate of change or our slope, which we talked about yesterday, and then our initial value or our y-intercept is the add-on at the end or the constant, which makes sense because that's the constant value that doesn't change. The slope keeps the values keep changing as you use the slope and you make new points. The y-intercept is always the y-intercept. So that's how you see it in an equation. In a graph, you can just see where it crosses the y-axis, and that is your starting point. And then you use that to go to the next point to find your slope. Again, things we've already done before. We're just kind of doing a little review this week. All right, let's keep going. So, this, I didn't put the question here. Drag to the starting points. Okay, so let's look at which equations have a starting point of -3, meaning that they have a constant of -3. I know what you guys might be thinking that this does here, but no. That is actually, if I rearrange this, because it has to be mx plus b, if I take that -3 and I bring it over here, that would actually be a -3x plus 3. So actually, that's going to go in our, let's just drag it over to our 3 column, because that has a y-intercept of 3. This has a y-intercept of 3. This would have a y-intercept of -2. And this has a y-intercept of plus 2. Oh, the poor -3 is lonely. There is none there. Sad. Okay, so just a little warm-up exercise. All right, which linear functions have an initial value of -4? I know that this one is 5, so that's not it. This one is also 5, so that's not it. Again, here, if I rewrite this like that, remember subtraction is add the opposite. And I use the commutative property to switch these addends around. This is actually y equals -5x minus 4. So this has an initial value of -4 if I move those around. Remember, the initial value is the constant, not the one with the x or the coefficient. All right, let's keep going. Okay, so the graph represents Josie has 1.5 cups of water in her watering can, then she fills it. Water flows in a rate at 1 cup every 4 seconds. So rate of change of the function is going to be, that's my next perfect point. So my y goes from 2 to, oh no, it's from 1.5 to 4. Oh wait, no, we can just get this from the word. Rate of change, it goes up 1 cup every 4 seconds. So our rate of change is 1/4. Sorry, I'm making that more complicated than it needs to be. 1 cup every 4 seconds. Again, so our change in y, it would go up 1 cup, and then our change in x would be 4 seconds. So slope of the line is 1/4, because rate of change and slope are the same things. The y-intercept and the initial value, again, those are the same thing, and it says up here, we're starting with 1.5 cups. That's what was already in the can. And that's the same as our y-intercept. So our function rho now is going to be mx plus b. M is our slope, b is our y-intercept. Y equals 1/4 x plus 1.5 or 1.5. I just I like everything as a fraction. And so that's what that would look like. All right, let's keep going. What is the rate of change in the initial value for this function? So we see here, let me move myself. We see here that the initial value is 8. I'm going to write that above this. And then the rate of change is, actually I can use this point here. If I go, I'm going to use that one. If I go down 4, from 8 to 4, over 2, so minus, and then 2, negative 4 over 2 would just be negative 2, so that's my rate of change, or my slope. So my equation would be y equals negative 2x plus 8, starting at 8 and then going down. All right, let's keep going. Hi there. Okay. The wave function in the graph models the height off the ground of a person riding a zip line. So how high off the ground is the platform? In other words, that's our starting point because we're starting on the platform and then starting to go down. That's our starting point here. So you're going 100 feet up to start and then you're going down. So that platform is 100 feet off the ground. I'm not going on that. That's way too high. All right. Function 125 plus ADN models the amount of money in dollars the zipline ticket cashier has in her hand after selling tickets. How much money did she have in the register before selling any tickets? If I write this in y equals mx plus b, this would be y equals 80x, because that's our coefficient and variable, plus 125. So she originally had $125 because, and then she's adding 80 per ticket. So our starting point was 125. Our rate of change is 80. And that is it for today. And then Bear wants to say bye. Oh, you can't see him. All right, I will see. All right, Bear. There he is. All right. Bear, say come to Zoom at 10. Come to Zoom at 10. All right, guys.